Hello guys, today I'm gonna discuss to you the chapter 12 of the CCNA version 7 bridging, switching, routing and wireless essentials, which is the chapter 12 is about the WLAN concepts, and it have 8 parts, which is the introduction to wireless, WLAN components, WLAN operation, CAPWAP operation, channel management, WLAN threads, secure VLANs, and processing quiz. First, we go to the introduction to wireless, and under that is the benefits of wireless. A wireless LAN or WLAN is a type of wireless network that is commonly used in homes, office, and campus environments. Networks must support people who are on the move. People connect using computers, laptops, and tablets and smartphones. There are many different network infrastructures that provide network access, such as wired LANs, service provider networks, and cell phone networks, but it's the WLAN that makes mobility possible within the home and business environments. These days, the use of the technology has been the greatest gift to the millennials because it helps them to study more, and it makes the what you call this, the way of them of studying to be easy because they don't have to do readings on the books, because the topics that they need to know is they they can find it on the internet directly on the sites that the schools provided using the wireless LAN. Now, in business, with the wireless infrastructure in place, there can be cost savings anytime equipment changes or when relocating an employee within a building, reorganizing equipment or a lab, or moving to temporary locations or project sites. A wireless infrastructure can adapt to rapidly changing needs and technologies. Next is the types of wireless networks. Wireless networks are based on the Institute of Electrical and Electronics Engineers, which we know as the IEEE standards, and can be classified broadly into four main types, which is the WPAN, WLAN, WMAN, and WWAN. First is the WPAN, or the Wireless Personal Area Network. Uh, it uses low-powered transmitters for a short-range network, usually 20 to 30 feet or 6 to 9 meters, and Bluetooth Zigbee-based devices are commonly used in WPANs, and WPANs are based on the 802.15 standard and 2.4 gigahertz radio frequency. And wireless LANs or WLAN uses transmitters to cover a medium-sized network, usually up to 300 feet. WLANs are suitable for use in a home, office, and even campus environment. WLANs are based on the 802.11 standard and a 2.4 gigahertz or 2 or 5 gigahertz radio frequency. Wireless LANs are mostly used by students and business owners, and wireless MANs or WMAN uses transmitters to provide a wireless service over a larger geographic area. While MANs are suitable for providing wireless access to a metropolitan city or specific district, WMANs use specific license frequencies. This is mostly used in the cities or in the government offices. They use this to give to give to give give Wi-Fi for the people. Next is wireless wide area networks. Use transmitters to provide coverage over an extensive geographic area are are suitable for national and global communications and also use specific licensed frequencies. Next we go to the wireless technologies. Wireless technologies use the unlicensed radio spectrum to send and receive data. The unlicensed spectrum is accessible to anyone who has a wireless router and wireless technology in the device they are using. And here are some wireless technology that we normally use nowadays. Uh, First, we have the Bluetooth, an IEEE 802.15 WPAN standard that uses a device pairing process to communicate over distances up to 300 feet or 100 meter. It can be found in smart home devices, audio connections, automobiles, and other devices that require a short distance connection. There are two types of Bluetooth radios. First is Bluetooth Low Energy or BLE. It supports multiple network technologies, in, including mesh topology to a large-scale network devices. Bluetooth Basic Rate Enhanced Rate or BREDR. This supports point-to-point topologies and is optimized for video streaming. This is what is we commonly use on our phones. Next is the WiMAX or Worldwide Interoperability for Microwave Access. It is an alternative to broadband wired internet connections, competing with DSL and cable. However, it is typically used in areas that are not yet connected to a DSL or cable provider. It is an IEEE 802.16 WAN standard that provides high-speed wireless broadband access of up to 30 miles or 50 kilometers. That's so far. WiMAX operates in a similar way to Wi-Fi but in a higher speed over greater distances, and for a greater number of users, it uses a network of WiMAX towers that are similar to cell phone towers, and the transmitters and cellular transmitters may share space on the same tower as shown in this figure. You can see here, this is the sample of the tower of a WiMAX. Next is the cellular broadband. Cellular broadband or 4G to 5G are wirelessly mobile networks primarily used by cellular phones but can be used in uh, automobiles, tablets and laptops. Cellular networks are multi-access networks carrying both data and voice communications. A cell site is created by a cellular tower transmitting signals in a given area. Interconnecting cell sites from the cellular network. The two types of cellular network are Global System for the GSM, and Code Division Multiple Access or CDMA, and GSM is internationally recognized, while CDMA is primarily used in the US only. Next is the satellite broadband. It provides network access to remote sites through the use of a directional satellite dish that is aligned with a specific geostationary Earth orbit satellite. It is usually more expensive and requires a clear line of sight. Typically, it is used by rural or homeowners and businesses where cable and DSL are not available. Next, we have the 8.802.11 standards. The world of wireless communications is vast. Yes, very, very vast. However, for a particular job-related skills, we want to focus on specific aspects of Wi-Fi. The best place to start is with the IEEE 802.11 wireless standards. These standards define how radio frequencies are used for wireless links. Most of these standards specify that wireless devices have one antenna to transmit and receive wireless signals on the specified radio frequency, 2.4 GHz or 5 GHz. Some of the newer standards that transmit and receive at high speeds require access points. Here is the here's some IEEE standards. Wallen standard. We have here the IE1 standard 802.11 with a radio frequency of 2.4 GHz and the speed is up to 2 Mbps. Next is the 802.11a which has the radio frequency of 5 GHz and it has the speeds of up to 54 Mbps and it only covers small coverage area and it is less effective at penetrating buildings structures and not operable with the 802.11b and 802.11g. Next is the 802.11b, which has a radio frequency of 2.4 GHz and it has the speeds of up to 11 Mbps, longer range than 802.11a, better able to penetrate building structures. Next is the 802.11 G, and it has a radio frequency of 2.4 GHz and it has the speeds of up to 54 Mbps, and it is a backward compatible with 802.11b with reduced bandwidth capacity. 802. Next is the 802.11n, which has the radio frequency of 2.4 GHz to 5 GHz. Data rates of this is range from 150 Mbps to 600 Mbps with a distance range of up to 70 meters or 230 feet. Next is the 802.11 AC, which has the radio frequency of 5 GHz, provides data rates ranging from 450 Mbps to 1.3 Gigabps, and using MIMO technology, and it can support to up to 8 antennas. And lastly is the 802.11AX, which has the radio frequency of 2.4 GHz to 5 GHz, and it has been only released into 2019, and this is the latest standard of the WLAN. And next, here is the wireless standard organizations. First, we have the ITU, or which is the International Telecommunication Union. Uh, function of this is it regulates the allocation of the radio frequency spectrum and satellite orbits through the ITUR. ITUR stands for the ITU Radio Communication Sector. Next, what we tackled earlier is the IEEE. Uh, it specifies how a radio frequency is modulated to carry information. It maintains the standards for local and metropolitan area networks. Uh, Next is the Wi-Fi Alliance. The Wi-Fi Alliance is a global or a non-profit industry trade association devoted to promoting the growth and acceptance of wellness. It is an association of vendors whose objective is to improve the interoperability of products that are based on the 802.11 standards by certifying vendors for conformance to industry norms and adherence to standards. Next, we go to the 12.2 of wireless components to the wireless and ICs. Here we have our wireless home router, the type of infrastructure device that an end device associates and authenticates with various based on the size and requirement of the WLAN. And we have this the wireless home router, access point, switch and router, and wireless. We go to the wireless access points. While range extenders are easy to set up and configure, the best solution would be to install another wireless access point to provide dedicated wireless access to the user devices. It's like this is like the Wi-Fi extender that we commonly bought on some stores. AP categories. AP categories can categorized as either autonomous APs or control-based APs. First, what is the autonomous APs? These are standalone devices configured using a command line interface or a GUI. Next, the control-based APs are the devices required no initial configuration and are often called lightweight APs. Here you can see here the APs. Wireless antennas. Here are some wireless antennas. First, we have the omnidirectional antennas. These antennas, such as the one shown in this figure here, provide 360-degree coverage and are ideal in houses, open office areas, conference rooms, and outdoor areas. Next is the directional antennas. Which antennas focus on the radio signal in given direction. This enhances the signal to and from the AP in the direction the antenna is pointing. MIMO antennas, which is the multiple input, multiple output. It uses multiple antennas to increase available bandwidth for IEEE 802.11 and or AC or AX wireless networks. Up to 8 transmit and receive antennas can be used to increase throughput. Next, we go to the 12.3, the WLAN operation. We go faster here. Yes. Go to the H2.11 wireless topology modes, which is the ad hoc mode, infrastructure mode, and tethering mode. Ad hoc mode is this when two devices connect wirelessly in a peer-to-peer manner without using APs or wireless routers. An example of that is the wireless clients connecting directly to each other using Bluetooth or Wi-Fi direct. Infrastructure mode is this is when a wireless client interconnect via a wireless router or AP such as in VLANs. APs connect to the network infrastructure using the wired distribution system such as Ethernet. Next, the tethering, a variation of the ad hoc topology, is when a smartphone or tablet with cellular data access is enabled to create a personal hotspot. Okay, this is the example of the tethering hotspot that we commonly use when we go to play some games using Wi-Fi and multiplayers. Next is the BSS and ESS. Infrastructure mode defines two topology building blocks, a basic service set or BSS and an extended services set or ESS. BSS is consists of a single AP interconnecting all associated wireless clients. Two BSS are shown in the figure. Here you can see the two BSS and ESS is the external service set is when a single BSS provides insufficient coverage. Two or more BSS can be joined through a common distribution system into an ESS. You can see here the ESS. The passive and active discover mode. See, in passive mode, the AP openly advertises its service by periodically setting broadcast beacon frames containing the SSID supported standards and security settings. In the active mode, wireless clients must know the name of the SSID. Next, the CAPWA. Oh, we're gonna go jump in here. We'll go to the important parts of this chapter. So here, DTLS encryption. DTLS is a protocol which provides security between the AP and the WLC. It allows them to communicate using encryption and prevents eavesdropping or tampering. Next, the Flex Connect APs. We have two modes of operation for the Flex Connect AP. First is the connected mode, which is the WLC is reachable. Next, the standalone mode and the WLC is unreachable. Go to the 12.5, which is the channel management. frequency frequency channel saturation. Here, frequency channel saturation. Sorry, guys. DSSS, direct sequence spread spectrum. This is a modulation technique designed to spread a signal over a larger frequency band. Spread spectrum techniques were developed during wartime to make it more difficult for enemies to intercept or jam a communication signal. Next, the FHSS, or the frequency hopping spread spectrum. This relies on spread spectrum methods to communicate. It transmits radio signals by rapidly switching a carrier signal among many frequency channels. Next is the OFDM, or orthogonal frequency division multiplexing. This is a subset of frequency division multiplexing in which a single channel uses multiple subchannels on adjacent frequencies. Now we go here to the last part, which is the secure balance. Go to the SSID cloaking and MAC address filtering. MAC address filtering. You can see here, guys, the 802.11 original authentication methods. We have the two types of authentication were introduced with the original 802.11 standard. First is the open system authentication. Any wireless client should easily be able to connect and should only be used in situations where security is of no concern, such as those providing free internet access like cafes, hotels, and or in remote areas. Next, the shared key authentication provides mechanisms such as WEP, WPA, WPA2, and WPA3 to authenticate and encrypt data between a wireless client and AP. However, the password must be pre-shared between both parties to connect. Yes, you can see the shared key authentication method, the authentication method, the word equivalent privacy, the Wi-Fi protect access, the WPA2, WPA3, the description here, you can see the description here. Authenticating a home user, we have the personal and enterprise. The encryption, last T is the WPA3. At the time of this writing, devices that support WPA3 authentication were not readily available. However, WPA2 is no longer considered secure because WPA3, if available, is the recommended 802.11 authentication method. WPA3 includes four features, which is the WPA3 Personal, WPA3 Enterprise, Open Networks, and Internet of Things IoT onboarding. The WPA3 Personal and WPA2 Personal threat actors can listen in on the handshake between a wireless client and the AP and use a brute force attack to try and guess the PSK WP3 personal threats. This attack by using simultaneous authentication of equals SAE, a feature specified in the IEE. WPA3 and the enterprise still uses 802.1.1x EAP authentication. Open networks in WPA2 send user traffic in an authenticated clear text. In IoT onboarding, although WPA2 include Wi-Fi protected setup, and WPS to quickly onboard devices without configuring them first, WPS is vulnerable to a variety of attacks and is not recommended. Thanks guys for watching, that's all.